Thank you. So we're recording the session today. If may I request all our panelists to please keep their videos on. It's a little more interactive for the audience. Great. Okay. Good morning, everyone. Thank you for joining this webinar. Today, we're talking about an issue that has raised major concerns in the electric vehicle industry as well as among consumers. In the last 4 months, there has been a sharp increase in the cases of EV batteries catching fire under different conditions and geographies. Some reports indicate that close to 38 electric two-wheelers have caught fire while either being transported, just parked on the road or in showrooms, and even during charging. This has raised questions about the safety readiness of these batteries and whether they can support the sharp growth EVs are witnessing in India, especially in the two-wheeler segment. These incidents have dampened consumer confidence in EVs, which was growing well as the sales indicate, and they've also highlighted gaps in the quality and safety protocols that currently govern the EV market in India. In our discussion today, we're talking about what's causing these batteries to catch fire, what are the gaps in protocols across quality testing and manufacturing, and finally, what the government and industry needs to do to ensure highest safety standards for EV batteries. I'd now like to introduce our panelists for the session. We have with us Mr. Rahul Lamba, CEO of the Energy Company, which specializes in making faster, reliable, and cost-effective EV batteries. Mr. Lamba has in-depth experience in designing lithium-ion batteries for automotives and stationary storage needs. He has also led technical due diligence efforts for investments in electric two-wheeler startups and conducted technical trainings at the Automotive Components Manufacturers Association. We are also joined by battery expert, Professor Sagar Mitra. He is an associate professor at the Energy Science and Engineering Department of IIT Bombay and holds a PhD in solid state electrochemistry. He's currently leading the battery research team at the National Center for Solar Innovation, incubated at IIT Bombay and supported by the Ministry of New and Renewable Energy. Our third and final panelist is Mr. Shresht Mishra, co-founder of Simple Energy. Simple Energy is an electric vehicle startup company based in Bangalore who recently unveiled their first electric two-wheeler, Simple One. It has attracted a lot of attention in the market, and the first batch of products are expected to be out by mid of this year. The company has a strong focus in research and development and are building many components of their scooters in-house, including the batteries. A very warm welcome to all our panelists, and thank you so much for taking the time to join us today. I will now hand over the discussion to our moderator, Srishan Venkatesh, Senior Analyst and Editor of Carbon Copy, a digital platform that tracks updates and developments in the climate and energy sector. Over to you, Srishan.
Thank you so much, Sonali, and welcome to everyone. Thank you so much for joining us today. As emerging technologies approach mainstream commercial adoption, they inevitably confront questions of public interest, safety, and how they need to be addressed regulatorily. We have seen such inflection points time and again when dealing with innovation and technology, notably with electricity soon after its discovery and during its commercialization, with conventional vehicles in the early 20th century, and when public safety was a huge question that needed regulatory addressal. And most recently, we've been on a 20+ year long journey when it comes to regulating the internet and content on the internet. India's EV journey seems to be evidently at one such inflection point. The reported incidents that Sonali also mentioned have forced the government to take a closer look at safety standards and testing protocols, while manufacturers have been forced into recalls and new launches have been halted. So today we'll attempt to get to the bottom of the issue of fire safety in EV two-wheelers, how these can be effectively addressed. And without any further delay, I think we can jump right in into the why, or why of why when dealing with EV fires, why are these happening? What are the gaps when it comes to the standards that are required to be adhered to? Are there technologies that are less risky than others, and so on? All the questions that we have are pretty broad-based and have implications across the value chain. So at any point, if anyone wants to intervene or say something, please don't hesitate. Just let me know. But first, I'd like to invite Dr. Mitra to to kind of take us through why there have been why there has been this spike in reported fire incidents across the country, and whether it has anything to do with the external conditions such as charging, or whether it's parked, whether it's being transported. Could you just please take us through and maybe clarify um, the possible explanations to these fires?
Yeah, thank you for inviting me here. This is a good time to discuss about all this in starting fundamentally very basic way, so that most of the people understand what is maybe wrong, or maybe what are the things need to be done. So if you look at the conversion in scientific term is three factors are involved in conversions. One is fuel, other one is oxidizer like oxygen, and third one is ignition. So you need to ignite to start this. There's a triple point, need to meet together, and then the fire starts. So this is the basic points. So whatever fire is happening. So if you look at what are the source inside your lithium-ion battery right now. So oxygen is mainly coming out of the cathode, whatever, if you're using any NMC or even LFP also, oxygens are there. So PO4 is oxygen source. So oxygen source mainly from the cathode sides. If you are overcharging, the oxygen comes out from the crystal structure. That is known. The other side, fuels. What is the fuels? The main fuels is the electrolyte, which is the electrolyte right now, which is flammable in nature. And other side is anode, which is also graphite. I'll talk about one by one, very simple way, so they'll understand what is the fuel, what we are talking about. Fuel. Ignitions, that's the main problem. So we are not igniting it. So that could be several things can be ignited. So one could be, look at it like a temperature. Temperature can be one ignition problem. Second point could be your vibration, lot of vibrations, or wrongly mechanical maybe pressure was introduced there. So you can actually chalk it out what could be the ignition points. So when this point starts, you are creating this point, the ignition, a small amount is created. So all other things are available. So that catches fire. So if you have asked these questions, the fuels we have, let's say fuels in any batteries are very small amount. Like electrolyte in liquid electrolyte is very small amount. And cathode right now, we are very standard cathodes we are using. And I see that a lot of people blame the chemistries. I don't think it's the blaming on chemistries, the single point of agenda. You should maybe blame so many other things also. It is not that correct way to blame. Okay, so if you look at it, the main problem, if you look at the more like a fuel is the electrolyte, the major quantity in the available. But compare, you see that IC engine, the 30-40 liters of fuels, which is more flammable compared to even liquid, which is available in the lithium batteries. Okay, it's very small. But we are very safe with the IC engine. So it is not that IC engine doesn't catch fire, still it's catching fire. So we need to see how we pack it. So if I start blaming one by one, so what is going wrong right now? So blaming starts from the cell itself. Because I work on the cells, so I start blaming the cells. Right now, if you look at the most, let's say stable, as per our knowledge, stable cathode is LFP, lithium iron phosphate. Because the oxygen evolution of this cathode structure is quite difficult. And if you take singly lithium iron phosphate, is decomposed or crystal structure defects happen, temperature of above 250. It is hardly have that temperature reached by any conditions, unless until you are in a runaway situation, like a second stage of runaway, where everything cascades and then temperature increases anyway. But that's the reason it is very safe. Next safest what we are using in electric vehicle right now is NMC, is a different composition of nickel, manganese, cobalt, which is slightly less thermally stable. If I compare it the single way, like a one cathode to other cathode, it is less stable because its temperature around it started decomposing is around 170 to 180, depends on which composition you are working on. So more nickel content, if you have more energy needs, more nickel content is added, and that is less safe, higher, means not safe because the temperature is coming down. And the third one is the fuel. If you have any degradation, so that's another thing. What I feel in India, maybe in high, like our climatic condition where ambient temperature is slightly high, there are all the decomposition reactions inside the battery. So first decomposition may be we know that we have a surface layer called ACI, which is happened on the anode side. Once we construct the battery, we condition the battery before selling to anyone. So that's conditioning actually making the surface film on the anode side. So if you are temperature above 60 to 70 degrees centigrade, this film actually degrades. So degradation of this film creates a further electrolytic compositions. And once you have a degradation of this, so what happens? You are creating a lot of methane or hydrocarbons product inside the battery. That's called degassing. And that degassing, anything is a chemical kinetics. So if you have increased the temperature, the chemical kinetics is more, like a more favored. So all degradation favored the higher temperature. So one, maybe you can blame certain percentage. I don't want to put a percentage. Put a factor, let's say temperature is one factor. So we need to cool down the battery during charging as well as in operation. That's a very basic fundamental. You don't have to do anything. Cool down the battery. So if you are not cooling down, the degradation is a problem. So degradation creates this hydrocarbons, and you know the methane is also a fuel. It's easily catching the fires. You don't have to degrade further the electrolyte. So these things are one by one adding your on your battery. So first is starting is the degradation of ACI, and then melting of separator. But right now industry is using ceramic coated separator. The melting point increased to 138 to 140. So it's very difficult to increase that internal temperature that level, but it happens. So why it happens? Maybe we are actually starting any combustion situation inside the battery at lower temperatures. Okay, so even we use that separator to melt and then stop the battery. So that's another technology is going on right now. But it happens, we are catching fires. We need to find out what is the wrong. So if you look at the major problems right now, battery or the same things are coming up. One is you can blame the components, like the cell components, how you are packing the components, and there is any mechanical shock or any other external conditions are implied so that it's battery getting maybe tension or something happening that creates the fire. And third one is your misuses, like a charging. So charging may be not done properly. It is also uses, like if you are rating your rating is something, but you're withdrawing more due to your wrong BMS or wrongly you are putting some circuits so that it creates an abnormal situation. So you are actually exceeding that safe limit of the battery operations, and that catches the fire. So if I sum it up, that's a few things what we can think about. One of them may be wrong, or maybe many things are wrong. I think I'll maybe stop it here. I can add more and more technical terms during the discussions. Thank you.
Yeah, so there's quite a bit to unpack in what you said. You mentioned that this is basically a culmination of multiple factors. Like, just logically, the next question towards any of these kinds of developments is to minimize the risks in all of these different factors. So is there a regulatory way to do this? Rahul, I know that you have some experience with assessment of the technical thresholds when it comes to investments in two-wheeler companies. I just want to get your opinion on where we stand currently when it comes to regulating this. Is there a way to regulate this aspect of battery manufacturing without having detrimental impacts towards innovation or developing the technology itself further?
So thanks first for inviting me. So just adding to what Professor Mitra was saying, I guess my voice is audible. There's too much background noise here, so I'll try to be slightly louder. So see, I'll just add to a few points to what Professor Mitra was saying. So see, one part of a failure is actually coming from cells, but there are two other aspects to it, which one must think about. One is the poor pack design, because when we say we have a battery pack will have say 100 to thousands of cells, depending on what kind of battery size we are considering. So we really need to think about how we need to package these cells together so that even if in a failure case, say one of these cells goes bad, the failure is not propagating to all the other neighboring cells. That is something which battery pack manufacturers need to think about. And this has nothing to do with I would say, cell and nothing to do with vehicle manufacturers. This is something which battery pack manufacturers have to take care, because they are the ones who are packaging the cells inside the battery pack. And another set of responsibility that has to come to battery manufacturers, I would say, is designing a proper BMS, a battery management system. So as Professor Mitra was saying, that batteries are actually thermally stable up to a certain temperature. Now, beyond a certain temperature, they're actually going into a thermal runaway state. So a job of a BMS, a battery management system, is to ensure that we do not go in that particular state. The concern that we have today in industry is that people are not developing their own battery management systems. Many companies, I would say, many flag bearers, torch bearers of the industry who are claiming to be designing safest batteries out there, even they are not designing their own battery management systems. So it's what they are doing is they are getting battery management systems off the shelf from China, which does not have basic protections in place. They are just assembling cells together, placing the BMS and just selling those products out there in the market, because they are under a FOMO that they don't want to miss out, and they want to like sell more and more so that they can increase their valuation and they can get more funds out. But we need to understand as battery manufacturers that we are actually responsible for an individual's revenue, his salary, and at the same time, we are responsible for an individual's life. And when we are responsible for an individual's life, we are responsible for his whole family life as well. So the reason being, majority of vehicles are used by people who are using them for deliveries. So if any one of these vehicles is actually catching fire, and due to any unforeseen circumstances, if a person dies, which is, I would say, the most unforeseen incident that has happened multiple times recently, we have actually stopped the revenue for the whole family itself, which is the most disturbing element. So I would say battery manufacturers need to see inside and understand that are they confident of the technology that they are selling outside? And if the answer is no, then they should seriously reconsider of reevaluating their battery packs. So
that's very interesting. No, it's very interesting that you bring in the supply chain of batteries themselves and the associated technology, the battery management system, into question. Now, like economically, it's probably more efficient, more cost efficient, more profitable to just import batteries from abroad, notably from China. Is it a question of incentivizing further battery manufacturing over here, or is it a question of bringing in other kinds of policy levers like domestic content requirements, for example, for manufacturers here? And is that the way to address this in the absence of one unified global standard that you push on both sides?
Yeah, so the way I would like to see it is that we should start increasing tariffs on the battery packs on the companies which are getting complete battery packs from outside. At the same time, if we are providing more incentives to domestic battery pack manufacturers, it will help them in spending out more money on research and development. And that is the only way I think so that India will start seeing some core deep tech startups who are creating products which are actually launched and which are creating an impact out there in the market. So even though the government incentivizes under FAME, but a sad reality of FAME is that what many vehicle manufacturers are doing, they are getting parts from China. They have included a third party, which is rebranding that component and making that to an Indian supplier brand. And then they are showing in the final invoicing that this component is coming from India, which is actually the most saddest part, because the whole objective of such companies is to mint out easy money. So I would say on the regulatory side, the government has to be more aware of such things, and they should actually penalize those companies who are actually caught red-handed using this.
Got it. Professor Mitra also mentioned the nickel content in the technologies. You mentioned the BMS, the importance of the BMS. There are competing technologies in the market. Is there, when it comes to standardization of, Professor Mitra also mentioned the need to, although lithium-ion batteries are stable, there is still a need to for cooling. when it comes to charging. Is there a industry accepted or a policy mandated standard that currently exists that ensures all of these? Are there protocols that already exist? This is pretty much a question for all three of you. For Shresh, for you, it is also to kind of gauge where you are coming from when it being an indigenous manufacturer who, when I went through your website, I thought a lot of your claims would depend on a dependable or on a very reliable battery technology. So I would be interested in hearing that side of things as well. You can go first, and then of course Professor Mitra and Rahul, please feel free to add on.
Sure, thank you so much. So as Professor Mitra was saying, that the mechanical shock or mechanical vibration that is induced in the battery pack. So it's not just the battery pack casing, as Rahul was mentioning, it's also about choosing the right cell, because there are energy cells available in the market, as well as power cells are available in the market. So you have to choose the right cells and you have to test them rigorously, because when you talk about automotive battery packs, in fact, it has the capacity to injure people and kill people at times as well. And that's a very serious concern that needs to be taken into consideration while designing battery packs or the vehicles. So, and also when I completely agree with what Rahul said, that a lot of companies are parachuting a product from a neighboring country and trying to sell it into the Indian market. That's kind of a short-term goal, like quick sell, quick buck kind of a thing. And the government is also getting in more stringent rules and regulations in order to cope up with the FAME subsidies that all these companies are trying to take. So they will now be going to the tier 2, tier 3 vendors as well, in order to ensure that all the things are manufactured, or if not manufactured, at least the lithium ion cells and the microcontrollers and all those which are not manufactured in India can at least be assembled in India with a proper procedure. So all those things are coming into the picture from the government's perspective. And also one thing that Srishan, that you said, that government has halted new launches, that's that's actually a fake news that was circulated. So the government has recently announced that there is no halt on launching new vehicles. And from our Simple Energy's perspective, we decided to design, develop, and will be manufacturing our own battery packs, motor controllers in-house, because that gives you the right leverage of what kind of technology, what kind of the performance that you want to deliver to the consumers. So that is why the choosing of right cells and also designing the BMS in accordance to what you want to build and how you want to build is very important, right? When you talk about there are two kinds of scooters available in the market right now: high performance scooters and the low speed 25 kmph scooters. So those are the things that you need to take into consideration, that when we talk about Simple One, we are making a high performance long range scooter. So everything has to be designed in such a way that, as Rahul was also, all the things Rahul and Professor Mitra mentioned, that if, for example, one cell catches fire or something bad happens to it, it should not propagate to the other parts of the battery pack, to ensure that there is no major problem, major, I would say, hazard to the customer or the vehicle, right? And that's the thing. So that is why you have to have multiple checks and barriers on designing, how you're designing the battery pack and how you're using it. So those are the things that definitely need to be taken into consideration. So right now, everybody's trying to build a battery pack. Even if they're choosing a BMS, let's say from some other market, it has to be properly tested. Because even if you're using something from off the shelf, it has to be properly tested and validated. Then only you can take it to the market or sell it to an OEM or use it for a purpose that can cause damage to the people, right? So all those things need to be taken into consideration. Apart from that, everybody's trying to reduce the go-to-market time. So that is also a thing that people need to understand. It's not about just minting money. It's about the safety of the consumers that you're selling your vehicles to. And apart from that, one more thing that I wanted to add is that I actually forgot what I was. If I would remember, I would definitely add it on.
No problem. Thank you for correcting me for that bit of misreporting. Because I was going to ask you also how that affects your plans, given that you're soon to launch. But I'm glad that there are no such delays. Rahul, Dr. Mitra, do you have anything to add when it comes to um, current current roles and responsibilities that manufacturers or the government share in addressing this risk, this space, and where where those regulatory lines should be drawn to kind of address all the different factors that could lead to elevated fire risks.
Yeah, Professor Mitra, you want to say something, or should I go first?
No, you can start.
Okay, thank you. So, see, on the regulatory front, I would say that the first standard which the government was using for testing of batteries was 048, and then they have recently changed it to 156. So on 156, certain things like certain abuse cases are tested, which is actually very good, and which is, I would say, at par with international level standards. But there are some corner cases which are actually not covered in those standards. Now, if I have to point out something, I would say one thing which has to be taken care of is connector life. So with the whole industry now moving towards battery swapping, where everyone says that they want to swap out batteries in order to reduce downtime, there is not a test which calls out that what is the cycle life that you are getting out of your connector. And in majority of the failure instances, what happens, the connector pins actually gets melted. And that is the point where the first short circuit happens. And that leads to the next level of concerns, and that leads to thermal runaway in the final stage. So that is something which I feel is not covered, which ideally should be covered. I'm happy that with the new battery swapping standard, they have actually talked about in document that they will be ideally covering this part regarding the connector mating cycle. The other thing that I would say is not covered is the way these batteries are actually vibration tested. So what is right now happening, people are testing out batteries as a separate component on a vibration shaker. Now, when they are testing out these batteries on a vibration shaker, it is not subjected to the same level of vibrations as it would have been in its actual case, once the battery is actually integrated inside the vehicle. So we have to think out some way that how do we mimic the actual scenario of how this battery is actually used on road while we are vibration testing these batteries on a bench. So these are, I would say, two things which are missing. On the regulatory front, I would actually strongly encourage government to do sample checks from mass production lots out of these companies. Because since this whole industry is very new, there is lack of quality practices which have been employed by various vehicle OEMs. So there are high levels of sample like component to component variation in the vehicles which is actually going out in field. So if there is random sample inspection by any third-party testing agency, that will also ensure that vehicle manufacturers are being pushed in order to make sure that all their components are consistent and they are meeting the quality standards against the vehicle which was actually showcased at ICAT during the vehicle homologation.
Yeah, so I guess the government is introducing that into the new norms. Post, I guess, July or June, they will be introducing this. They will be doing random testing on the battery packs from the line or the complete vehicle that they will be testing.
Exactly.
That's definitely a point that Rahul rightly said. And there are basic tests that, and when we talk about tests also, India is a very vast country. There are multiple kind of people and riding standards and temperature conditions. Everything is different. India as a country, the temperature ranges from 0 degrees Celsius to 50 degrees Celsius as well, right? So you're talking about a technology, lithium-ion technology, which has an ambient temperature to perform at 25, 35 degrees Celsius. So proper dissipation of the heat from the battery pack is also very important. Usually, I have seen a few batteries that have been cased in a plastic body that itself is insulating, right? So how will the heat generated inside the battery pack get transferred to the atmosphere? At the same time, pressure also builds into the battery pack. So all those things have to be taken into consideration while you're designing the battery pack. So that's the most important thing that people tend to kind of, I believe that people are trying to cut their cost at the expense of the quality that they want to offer to the consumer. Indian market is very happy to pay slightly premium amount in order to get a nice or good product that will not fail. That we have seen in the past in all the different industries, and it has been proven by multiple startups that have been in different industries. So people are willing to pay a slightly premium cost, but at the same time it has to match the quality standards that what is being promised to the people. When you're talking about transitioning from IC engines to electric vehicles, you cannot it has to be an apple to apple comparison, right? If let's say Activa goes up to a speed of 60, 65, 70 kmph, it cannot be replaced with a scooter that can give you 25 kmph speed, right? Because people are used to of using that, and in order to replace that, you have to give a product that can fulfill their needs and maybe something better than that. At the same time, you also are talking about the the fire incidences. When we talk about the data, still the IC engines catch more fire when we talk about per 1,000 vehicle. IC engines have a higher number of vehicles catching fire when compared to electric vehicles. So that is also there. It's just that the electric vehicle industry is booming right now. So it's more in the limelight, I would say. But at the same time, we need to make sure that that number goes down to zero, because when you're talking about vehicles, as I said, that it is a very important thing that the safety of the consumer needs to be taken into consideration. Price is something that maybe 5-10 rupees here and there, if makes a difference in the safety of the consumer is willing to pay that. So that is definitely that we need to take into consideration while testing. Also, testing agencies like ARI, ICAT, GARC, all these agencies need to take care of proper testing and proper sampling from randomly sampling from the production line. So that is definitely there.
Thank you. That was very helpful. And I hope we get to see the changes in testing rules come June or July. Professor Mitra, anything that you wanted to add?
So if you see, I was listening to everyone. So if you see what fire incident happening right now in our country, the numbers are very less. So I look at this as a probabilistic, it's a probabilistic factor. It is not a incident regularly happening. So if you see how many numbers of say vehicles are on road and how many are getting fired and what time is getting fired, which condition is getting fired, you will see if you put all this in one map, you will see it is a highly probabilistic, is a probabilistic problem. And you need to see in a other way to solve this problem. So one thing what I feel the knowledge is a very poor cell knowledge in India. That's this is very shocked to say, but it's the problem. In the cell level of knowledge, chemistry, forget about chemistry, cell level knowledge, pack level, and then in a module and pack level. So people are doing it without maybe not knowing much about what is there you're putting it and how to put it and how to optimize the situation and getting a less problems on this. So if you look at the fire incident right now, because of mainly two-wheelers are like a very high demand right now, and all incident mainly I think is two-wheeler right now, and four-wheeler is not much. So two-wheeler, if you look at it, an incident happened what time, that also gives you very much a good idea. If you see all incident happen at 11 o'clock to within or to 1 o'clock, so that shows so many things. And during even charging conditions. So that's another incident. We should look at it. So if you put all everything, you will get a lot of things and your understanding what is going wrong. I feel the knowledge need to be very much is a one thing, starting from OEM and then researcher, obviously involvement of researcher to the OEMs and what are the problems they're facing, that need to be put into the benchmark and then see how we can solve this. It is not a one person can solve. Maybe together it should solve in the industry's experience, industry's data is required. Otherwise, I cannot say what is going wrong. So I need to have data where it is happening and why it is happening. So I think investigation is much more important. And I am sorry to say we don't have any safety research in India till yet, even in the R&D level as well as in the, I don't know about industry much because I work with so many industries, but I don't see they have a research lab to talk about only this. I think Rahul was talking about, it's not the cell safety, it is talking about pack safety. So pack level research is, it is zero in our country. So this is one thing we should emphasize. and even policymakers also look at it, we should have institutes or take any IITs or whoever thinks that they can having that capability to handle that, do a pack level research that can help. Another problem, what I feel, it's a problem for two-wheelers, because if you look at two-wheeler and four-wheeler, the BMS is completely different. So very modern BMS having all the sensors which can sense not only temperature and voltage, also sense the gases involved, what is gases is coming out. But two-wheeler, we are not using that BMS. It is just a charge control we are using. Maybe that is one thing we should have. A moderate level of BMS should be added to the two-wheeler so that you can actually sense the pre-fire condition. Maybe it is going wrong, we should stop it, or replace the battery, or getting hot, why it is getting hot. All this information need to be stored and need to be shared with the researcher, or if the company having their own R&D, they should also look at it. And that is missing. Two-wheeler, maybe the cost cutting or cost saving, they are saving so many things, and that may be introducing a lot of, still if you look at the probability, the numbers, I don't know how many numbers are there in road, but how many numbers are actually happening in the incident, that is very, very small number. So that is also, there's a lot of things to look at. That's my opinion on that.
Yeah,
I definitely. Yeah, please go ahead, Ravi.
Yeah, sorry. So I was saying I do agree 100% with Professor Mitra that the numbers are actually low. But what I'll also suggest or I'll recommend from my side is that the central government should actually keep a repository for every OEM, for every particular battery make. What is the actual number of vehicles on road? What are the number of fire incidents that have happened? And we should have a proper central repository for it with an RCA done for every incident. So that will help all the other OEMs also in order to improve their products. And it will also increase the confidence of a consumer that, okay, these kind of failures have actually happened and companies have actually developed their products which are better, and so that these failures will not happen again in future.
Yeah, that would be interesting. Actually, this suggestion of developing a track and trace method had come up in a different discussion, but I would imagine that adding this as one of the variables in that track and trace mechanism wouldn't be too much of an addition to do, you know. And of course, like probabilistically, it does very much feel like a teething issue, although that is not to downplay the tragic circumstances or the tragic consequences of it. In terms of, if you had to look at it in terms of just numbers, then it does feel very much like something that will be sorted out. One thing that I got a sense of from all three of you was that whatever standards come up, whether it is in the testing side for the vibrations or the encasing or the way the cells are packed together, they have to be very customized for the Indian situation, Indian use cases, Indian road conditions, Indian temperatures, all of these things. What does this process look like? How long is this? Is there any global standard or industry best practices that can be leaned on? Yeah, this is also like an open question. All three of you work in spaces that are very closely aligned to these questions, so they're all kind of open for all of you. And before we get into that, I just want to remind our listeners that you can put in any questions that you have, and we'll try to get to them at the end between 12:30 and 12:45. But yeah, so with that out of the way, back to all three of you. Whoever wants to go first.
Yeah, so I would go first. So coming on to global practices, so I would say India is majorly economy which is driven on two-wheelers and three-wheelers. And two-wheelers or three-wheelers are most popular. I would say India sells the most number of two-wheelers and three-wheelers. So globally, we don't have a standard benchmark against which we can compare. So that is something which, because if we talk about European economies or even about North America, those countries, people prefer to drive four-wheelers around. And even if when they are driving two-wheelers, they are driving like 1000cc plus bikes. Whereas low power vehicles are predominantly used in India, China, and Southeast Asian countries, along with Africa and South American countries. So India, like we cannot consider like any other country benchmark test as a reference standard. What I think so we can do is we can bring in industry folks, who can add in their who can add in experience from their end, and then we had to, like, it will be a continuous journey. It is not that we, like, say 10 brightest minds of India sit one day in a room and they come up with a standard that has to be globally acceptable across India. It won't work that way. It is a brainstorming exercise which will have multiple rounds of iteration based on how we find problems arising and then how we circumvent those problems by ensuring that tests have been included in the test document.
True.
Thanks, Ram. Yeah, Shesh, please go.
Rahul rightly said that when you talk about standards from other countries like European countries or maybe US, so the conditions and the market is very different. The price point that what they are selling in US will not be viable in India. When we talk about, let's say, a company from Taiwan named Gogoro, they are selling at a scooter at around 4.5 lakh rupees. In India, that is not viable. Nobody will buy a 4. Maybe some people would, but a majority of the Indians will not buy a scooter that is 4.5 lakh rupees priced, right? At the same time, the Indian, as I was saying before as well, the Indian conditions are very different from European conditions when you talk about two-wheelers specifically. Two-wheelers, when the government says that only 2 people are allowed on the two-wheeler, but we all have seen that 3 people and 4 people also sit on it. So all those things have to be taken into consideration. The mechanical side of it, the electronic side of it, because when you add extra weight onto the vehicle, the motor has to draw more power from the battery pack, and that also affects the health of the battery, right? So at the same time, you cannot compromise on the safety of the consumer, that 3 people, 4 people are sitting, whatever the number is sitting on the vehicle, that has to be taken care of. So it's definitely there that all the things, the industry needs to sit together and draw some lines that where we want to build the vehicle, where we want to take this industry ahead. And standards need to come from the OEMs and from the government as well. It's a two-way thing, that not just the industry can set up the rules, or not just the government can set up the rules, because government has some standards which are definitely good, but are not able to surpass the safety standards that are required on road conditions. So that's the thing. It has to be a two-way road. The government should put in their efforts, put in their views, and at the same time, the OEM should also put in their efforts and their views. What are the things that need to be brought down and that needs to be followed.
Thanks, Shesh. Yes, Dr. Mitra.
Yeah, this is a standard, because it's very difficult to say, because I have a couple of companies in committee in this. It's difficult to say anything, because, but I can say we should not take one zone policies or charging infrastructure safety and then put it in our country, because our country problems are multidimensional. So you should, I think we should discuss with all OEMs and the users, because the users, if you look at it, how many the age, I was doing that actually. If you look at the age range, like which age actually interested to use this electric vehicles, is very interesting. So older people are not much interested right now for the using of electric vehicle because of all the incidents happening right now. So younger people are interested and their demand is different. So maybe they cannot wait more than, so all these things put it as a user's profile, and then OEM should have different profile, and then the policymakers should put into the profile matching and see and make it a good policy. That's my opinion, but I don't know how much is happening. I cannot say much more on this. Thank you.
Thank you. So, Shesh, you mentioned that it has to be very much a two-way street. Has it been a two-way street between different stakeholders so far, with any kind of standardization or regulation, that has been attempted so far? We'll get to the battery swapping and how far we've addressed fire risks in battery swapping, but just to gauge your experience in this area, and also yours, Rahul.
So from our perspective, we definitely are following the government standards because that is a necessity that all the OEMs have to follow. Apart from that, we have our own testing facility where we do all the cell level and the battery level testing when apart from the vehicle being integrated and then integrating into the vehicle, as Rahul rightly said, the total vibration on a vehicle would be different when we talk about the only isolated battery pack. So all those tests we do in-house. Apart from that, we want to do some tests that are not mandatory, for example nail penetration tests and all those things that we want to do in-house in order to ensure that our battery packs are safe, and we want to deliver battery packs that are safe for the market and for all the conditions, be it temperature like 0 to 5 degrees Celsius or maybe 50 degrees Celsius as well. So proper heat dissipation, we have multiple checks and barriers in our battery pack in order to ensure the safety, not the overcharge protection unit, charging protection unit. All those things are definitely there. Apart from that, we're using a phase change material in order to dissipate the heat from the batteries to the environment. So all those things we are taking into consideration. Apart from that, we would be more than happy to suggest some of the safety standards from our side to the government. Yeah, and I believe that all the companies should do that, whatever the safety standards are, and the government should take that seriously into consideration and then make maybe another standard for testing of the battery packs of the complete vehicle that will ensure the safety of the consumers and the products that are being sold in the market. And that's the only way people will believe, or people will not lose faith in the electric vehicle segment or electric vehicles market, because that's the future that we see, because you cannot be dependent on fossil fuels for a really long time. So that's definitely there.
Yeah. So answering to the question that you actually mentioned, that is the government doing something or is it taking feedback from the industry on forming out new policies and new standards? I would say they are. And on that front, I would say I wanted to congratulate the government that they have been like very senior ministers from the government. They have been very vocal about highlighting this as a concern, and they are like they have put out very strong words that in case such kind of things happen, companies will be penalized. That actually gives more confidence to a consumer that okay, subsequent products that will come out there, they will be much more better and they will be much more safer for any consumer. At the same time, they are considering, they are talking like central government is actually talking to many companies while it is and it is actually taking their feedback while it is working on battery swapping standardization documents.
Right. We can actually jump into that. It's been welcomed as a measure that will introduce better or better implement standards that already exist, that it will address range anxiety and so on. Rahul, you do work in the energy as services space. So given that charging points are a point of vulnerability when it comes to fire risk, how do you see this policy? How well has it been framed? Or yeah, just your perspective on the policy itself. Does it address this risk adequately?
So I would say right now the draft document which has come up, it talks about, I would say, 20,000 feet level perspective of things. So maybe once a detailed document comes out, we will be able to better understand that all the fire safety, I would say fire incidents have been well covered, and so that they do not occur actually on field. I would say regarding battery swapping, what we must understand, like we all say that whenever battery is being swapped, it has higher instances of catching fire, because at the same time, there are multiple packs which are stored in a swap station. So if one battery catches fire, it can propagate. So there are many news which is being spread like that. And I would say the news is true, but at the same time, it can be avoided very well through the technology aspect of it. I would say I'm an engineer, so I'll answer it in an engineering way. So if we need to have multiple redundant safety mechanisms in place that say if one level of protection in a battery pack has failed, we have a second layer of protection. If second layer of protection has failed, we have a third layer of protection. In that way, we'll always make sure that such kind of incidents, unforeseen incidents, do not occur on field. So say if a battery pack has a BMS and somehow the BMS is not working. Now, if the BMS is communicating to the charger then the battery pack can inform the charger that, see, my switches are not working well. Please stop charging me. And the charger will then stop charging the battery pack. It is always safe. What is happening in majority of the batteries out there in the market today is batteries and chargers are not communicating to each other. So even if battery knows that its switches have actually turned off or it is unable to control its switches, it is unable to communicate the same information to the charger. And the charger just keeps on pumping current inside the battery pack. And that is why we see maximum fire incidents happening during the charging stage.
Thank you. Thank you for that explanation. Professor Mitra, any perspective from your side on the policy, the draft policy that came from? Yeah.
Okay, I was given one interview recently. I think it will come on Monday, maybe, in the newspaper. So swapping technology, if you look at in ideal sense, is correct. It is good, but with a good benefit also brings from some negative points also. If you look at what a benefit you will get right now, infrastructure, the charging infrastructure is a major problem right now. The way we are going with the electric vehicle electrification, charging infrastructure has not gone up in that scale. So maybe the swapping station may not need that many. It may replace the charging stations right now for the time being. So the few charging like a swapping center in any city can handle whole city. That's another good thing. And always that swapping center the range anxiety maybe it will be less. But look at the other point. What I think Rahul was talking about, the state of health, which actually comes up once the swapping things are very high demand. Okay? When they're using very high amount of numbers of cells are more, number of cells means pack is more, how it was handled, how this information is analyzed, because analysis also takes time, how good computing you are using. This all may be a problem for our country because our country, demand is very high. So maybe a small country they can handle, but our country, but if you look at the China is doing that. There's that vast scale they are also doing. But I feel that we need to have more on supercomputing to understand the battery health and give that battery in the charging and then give that battery to the users. So that's my opinion. But these are good points on the swapping, I feel right now. But if it is once the complicated chemistries will be used, many different chemistries will be used, then the state of health will be a big concern because different chemistry, different conditions are, these things are different. It's like a different pockets. So how they will match it, it will be a very much challenging situation for even AI based computations. So that will be a challenge. I mean, we have to see that challenge.
Shresht, I know that you Simple has been working on its own charging solution. How does it, how do you see a swapping policy, and is the fire risk something that you have considered when you were figuring out your own charging solution?
Yeah, so let's start with the charging solution. So it has to be a proper communication between the battery pack and the charger, right? In order to ensure that what amount of current is required and how much current is required till the battery pack is fully charged, and overcharging it should not happen. At the same time, voltage fluctuation is a very common problem in India. Nowadays, it is reducing, but still that needs to be taken into consideration while using the charger and the battery pack. So these are the basic things that everybody, in fact, the mobile phones that we buy, the mobile phone companies have been telling us for almost a decade or more that use the same charger that we supply with the mobile, or the same specification of the charger that we supply with the mobile. So we have seen problems with phones as well, phones blasting, batteries catching fire and all that. So that's because of the type of charger that is required for the phone is different. Being used is different from what the companies have specified. So that's there. Apart from that, the swapping policy is something that we as a company feel is not a long-term solution, because when you talk about, let's say, if I have bought a new scooter, I have a new battery pack in it, and I go to a swapping station and swap it with the battery pack, which I don't know how it has been used. At the same time, how old it is and how it is going to perform. That is again a safety concern for the consumer. And also in the back of the mind of the consumer, it's always there that I bought something new and I'm replacing it with something that is old. So that's there. And apart from that, when we talk about a swappable battery, it becomes kind of like a public property. And unfortunately in India, we know how people use public property. So that's also a thing that people need to take into consideration. Swapping, there are multiple more issues in the electric vehicle ecosystem because it's a very nascent industry that can be solved just putting that we can solve all of it just by using swappable batteries is not something that I feel is feasible and not a long-term solution. Because as we said that you're talking about, let's say, a swapping station which will have 24 or maybe 12 batteries to swap. But if 12 batteries are swapped, and then what about the other people that are coming to that single swapping station? It's going to be a very complex, and it has to be very dense swapping station network that has to be there in the market, and even denser than the petrol pumps that we have right now in the Indian market. So that's definitely that people need to understand that there are multiple more problems that can be solved rather than just putting up a thing that you can swap the batteries. Maybe that would work for last mile connectivity or maybe deliveries, B2B deliveries. That would be helpful because there you have a single entity which is taking care of the complete swapping station and the battery packs and the vehicle. So there it is a controlled environment that you can use it for. But for the mass market or for consumer market, it's going to be a very difficult task.
And could you explain a little bit about your own solution, particularly as it pertains to like how you see fire hazard within that solution?
So as I said that it has to be a proper communication channel through the battery pack BMS and to the charger. It has to be properly communicating that how much charge is required and how and for how long it is required. So those things definitely, and fast charging is definitely there. But at the same time, fast charging will increase the temperature of the battery pack. That needs to be taken care of again. So all those things have been taken care of by when we're designing our battery packs. Proper design of the mechanical design of it, proper dissipation of the heat from the battery pack to the environment. So all those things play a very important role. And what people tend to forget that fast charging is definitely there, but it will degrade the battery life. So that also people need to fast charge only when it is needed. For example, if you have to go somewhere very quick and you don't have a lot of time, then you can fast charge it. Usually it is always recommended for the phones or the electric vehicles as well that you charge it at a advised rate 0.3C or some whatever the company advises.
Thank you. So there is, like, I suppose part of the whole the whole movement towards ensuring safety will involve consumer behavior and minimizing the consumer end responsibilities towards it to some extent. So we're almost towards 12:30. I'd like to invite all three of you to kind of give some final words on how you see this being resolved, how long maybe it would take for this part of the EVs debate to be answered once and for all. So Dr. Mitra, Rahul, Shresht, please, the floor is yours. And in case there are any questions, I'll get to them afterwards. There are a couple, so I'll we can get to them after you've given your time.
Yeah, the words as maybe summary words I can say is a beautiful product. That lithium-ion battery is you can see the market penetration is like any other battery compared to this is completely different, and very short time it has came to that stage. It's a very beautiful product and highly reliable right now. Quality control is like a 6 Sigma product. What I can say, use it safely. That's a main agenda. Use it safely, and you should know how to use it. That's a main thing. You should look at it and concentrate on the pack design and module pack design and how this will be integrated on your vehicles, so that you minimize all the shocks, like a physical shock or any other shocks, and use a good component. That's a major factor to remove at least 90% of your failure. That's mine. Another things I was talking about this, which is I forgot to say, this your swapping technology. So you are right now you are thinking of high like a fast charging. As a researcher on batteries, I don't like in fast charging. That means if you have a more electricity, or let's say charge you are consuming very fast, it is heating up the system. You know, the heating is a problem right now. So that is not a good idea, but we need to do it because we cannot stay 4 hours in the charging station. So that is swapping technology. Right now, battery swapping takes 7 minutes minimum. It's the swapping. That actually changes a lot of scenario because your battery is 6 hours charged, which is the ideal conditions. And then you are swapping in 7 minutes. I think that anxiety of time maybe is reduced in swapping. As I think one of your speaker was talking, yeah, that is, this may not be a long-term solutions, but for this country like us to start with electrifications and aware of this technology, and everybody should know what they're using, what are the benefits. It's a huge benefits. Pollution is a big benefits in terms of pollution is a big benefits compared to fossil fuel vehicles. And is one of the highest technological product right now. So in that sense, people should know from even OEM side, government side, even researcher side, we should propagate the news, or maybe knowledge should be disseminated so such a way that they should, everyone from the general public should know what they're using and what are the prospects and what are the problem if they're misusing it. So that's my final statement. Thank you.
Yeah, so adding to what Professor Mitra was saying, so I think so that standards need to be really strengthened up, though they are good right now, but there's still room for improvement. At the same time, companies have to spend more time on R&D, and they should try avoiding cutting corners, because one failure which is coming from a new brand is actually destroying their brand image as well. So they have to be more cautious while they are launching products in the market, that they have done all kind of protections and safety tests initially. And yeah, and I would say we all wish that the mindset of the consumer does not get affected because of all of these recent incidents, and they are still happy buying an electric vehicle. Along with that, I would say the final remark from my side would be that companies should have more confidence building measures at their showrooms, so that consumers get more confidence into the product. So maybe they can show some kind of abuse case actually in a showroom, and the customer is aware that, okay, even in such an abuse case, the battery is not going into a thermal runaway state. So such things will improve the confidence. And yeah, we all wish that India achieves the target that it has laid out of 30% penetration by 2030.
Yeah, so what Professor Mitra and Rahul said, I completely align with that, and there's nothing more to add to that. The most important thing that OEMs and the government needs to take into consideration is the safety standards, and that can only be followed when you have designed and developed things in-house, right? Because you cannot change or alter something that you have bought from the market according to your needs or according to the market's need. So that's definitely there. And apart from that, R&D is the solution to all the problems that we have right now in the electric vehicle segment, or any segment, to be very honest. So people need to work on that, and there are multiple more things that can be explored in the EV industry. It's just the starting of the industry, and there's a lot to explore in the motor side, motor controllers, BMS, battery packs, different chemistries of cells. All those things are there, and but it's just that it will take time, it will take effort, and people have to be patient. The OEMs who are trying to get to the market in like 3 months, 4 months, 6 months, that may be a short-term thing that you can make some quick money, but in the longer run, only people who are actually working on R&D and technology will be able to survive and will be able to support the complete ecosystem and take it forward.
That was great. Thank you. Thank you so much, all of you. There are 3 questions. The first 2 we have somewhat covered, but maybe if there is something more that any of you want to add, please go ahead. The first one is on some reports talking about how rising heat will impact battery safety. How true is this correlation? And if it is, how can that be addressed?
Should I take it?
Yeah, please go ahead, sir.
Yeah, this is Madhulika, I think. Yeah.
Yeah.
Yeah, there's a correlation that if you are rising rising heat, that impacts the battery safety. And how to do it is always recommended that when you do operations, charging or discharging, these are the two operation on batteries. So both time you should reduce the temperature or internal temperature by applying a thermal like a cooling system, or right now phase change material is used. So that's the best way to reduce the temperature, like a heat.
The second one also we just touched upon towards the end. What word of caution should be given to existing owners? What do they need to watch out for? I'll add my own little bit in there. Is it different for two-wheelers owners and four-wheeler owners? This word of caution?
Rahul or Irfan?
Yeah, I would take it up. So see, for four-wheelers, we have to understand that four-wheelers generally have an active thermal management system. So even in a higher ambient temperature condition, they are much more safer to be operated because the battery itself understands. And even as Professor Mitra was saying, very good battery management systems are used in four-wheelers. So it reduces the chances of failure significantly for four-wheelers. For two-wheelers, I would say there are some basic guidelines which have to be in place, which are good that any consumer is actually adopting them. That in case whenever you are coming directly back from a fully discharged battery pack, don't directly put it to charge. Give it some rest. Let the temperature cool down a bit. So such kind of basic, I would say, hygiene practices you'll find is common for all battery powered devices. So if you read about articles on how to improve smartphone battery life, you'll find out similar trends. And I would say if any two-wheeler consumer just reads few articles around it, they will get basic idea about how they can prolong the battery life and also how they can ensure that the pack is much more safer to operate.
And one more thing I'd like to add, that companies also need to educate people about electric vehicles, right? It's a very new market. You cannot just hand something over to the consumer and anticipate them to use it the way you have designed it, right? So you need to impart that kind of knowledge from the industry perspective I'm talking about. You have to impart that kind of, let's say, a handbook, because in IC engines also you get a handbook what to do and what not to do, right? So all those things have to also be considered, and the industry needs to impart that knowledge, whatever the knowledge the industry has gained over the time for developing or manufacturing, it has to be transferred to the consumer.
Thank you. The final question is from Mr. Manish Kumar about the policy draft shared by Niti Aayog on swapping that talks about smaller battery packs. Does it mean that if swapping is used, consumers will have to go to these stations almost daily? Hearing all three of you, it also felt that swapping has its value in depending on the use case that you want to see it. So maybe if this requires, is that a fair assessment to have, that people will have to go every day, or yeah, please.
Yes, so it actually depends on what kind of users a consumer has. For example, if my office is, let's say, 15 kilometers away from my home, I'd have to take 15 kilometers and 15 kilometer back. So it takes 30 kilometers. And depending on the smaller battery pack, I don't think it would be able to give you a range of more than 50 kilometers when you talk about on actual road conditions, acceleration and deceleration. So that's the thing. And definitely, as I said, that swapping is something that would require a very dense swapping station network, and our grids also should be able to support that kind of swapping stations put up. And apart from that, for B2B and last mile connectivity, you can work on it. But for consumers, it would be a very big hassle for them to go and swap the battery every day. In fact, sometimes 2 times a day as well. So that would be definitely a hassle.
Anything else to add? Yeah, please.
Yeah, I agree with what Mishra was saying. So see, I would say both technologies will coexist. We'll have fast charging, and even we are slightly more aligned towards fast charging. So we wish that fast charging, and we also feel that fast charging will see a market share of, if I have to put a number, say around 70-80%. because all consumers will be more aligned towards fast charging. As Mishra had already mentioned, that nobody wants to use a battery pack where he knows that it is a shared asset, and he is unsure about the quality of the product. For a battery pack which is integrated inside the vehicle, he feels much more confident that, okay, I know how I have used it. So I know that, I'm confident it will last for another 50 kilometers or 40 kilometers of range. Battery swapping is, I would say, a short-term solution. And as he had covered most of the points, I'm just reiterating it again. It will work well for last mile deliveries because for them, they want to reduce their downtime. But even for them, there are technologies, or I would say we are working on products which can solve their problems of downtime, about reliability, about other concerns using fast charge batteries. So, but in the grand scheme of things, I would think that both technologies will exist depending on the use case of the consumer.
Cool. Thank you so much. This was a great discussion. And yeah, we went through our time, it didn't feel like an hour, 10 minutes had passed. So thank you all for such a fruitful conversation. And hope to see you all soon again on another platform. But that's pretty much it from here. So yeah.
Thank you. Thank you, everyone.
Thank you.
Thank you, everyone. Thank you.